Okay. So yesterday I started with the parametric test, right? And we have discussed the t-test. I hope. Yes.
Yes, ma'am.
Yes. And in the t-test, we have seen one sample and two samples t-test. There are two varieties. Under two samples t-test, I discussed independent samples t-test. Today, I'll start with the dependent samples t-test and then we'll go to the one way ANOVA, right? So give me a second. I'm just going to share my screen. Okay. Okay. Am I audible, everyone? Hello, am I audible?
Yes, ma'am.
Yeah, thank you. I think there is some technical glitches, so I am going out of the meeting. Okay. My screen is visible?
Yes, ma'am.
Fine. So I need to see whether my video is properly supporting or not. Give me a second. Okay. So starting with the paired samples t-test. I hope I'm audible also and you can see my
Yes, ma'am.
right? Fine. Thank you so much. Starting with the today's agenda, today I'm going to discuss the paired samples t-test. So as we have already seen yesterday, the independent samples t-test, I tried to explain you that when the samples are independent of each other, in that case, and when you want to compare the mean in the two samples or in the two unrelated or independent samples, in that case, we are going for the independent samples t-test. Now, what if we are having two dependent samples, right? So in that case, we can use dependent samples t-test. The other name for this is paired samples t-test, right? So paired sample t-test is used also to find the significant mean difference. Here, the main thing is that, as you can read the slide, the paired sample t-test is useful when we want to determine whether the mean difference between two variables measured on same subjects at two different moments is statistically significant. So rather than saying two variables, usually we will be having a same variable, we will be having a same set of pupil, and we will collect the data twice for same variable from same pupil, right? I hope you understood what I said. I said we will be having one variable, we will be having same set of people, and we will collect data twice for the same variable from the same group of people. So in that case, we will be able to justify the pairing, right? So in the paired sample t-test, there will be pairing. Pairing meaning is that for a single person, you are collecting the data twice. So there will be some time gap, and in that time gap, you need to collect the data twice for the same group of people. And as I'm saying, for the same group of people, that means if suppose I'm taking 10 persons in the first conduct, so when I'll repeat this, same people should present there also. So that way it is a dependency. So if this kind of data is available to me, I want to find the significant difference in the two time gap or in the time gap, whether the significant difference is occurring in the variable or not. In that case, we can go for the paired samples t-test. I hope it is clear what I said.
Yes, ma'am.
Yes, ma'am. Ma'am, it is used for a test retest method, which you have
Yeah.
explained.
No, test retest method was the, ma'am, I told you that was the method of checking the reliability, right? It is not reliability. In the test retest reliability, that was the concept we have studied. That was
Okay.
for checking the scale instrument. But here we will be having the group of people. Say, for example, if suppose I'm talking about of my class only, right? Suppose in my class, before teaching any topic to my student, before introducing any new thing to the student, I want to understand whether they are having some basic knowledge about that or not. So maybe I can conduct one test or quiz, right? After teaching, again I can conduct the quiz using the same questionnaire, right? Or using the same test questions. That way, I want to see whether there is an improvement in the knowledge of my students or not. So
Okay, ma'am. Like post test and pre test.
pre-test, yes, post, pre, before, after, such kind of situation will be there when you're talking about the paired samples t-test. Fine.
Yes, ma'am. Understood, ma'am.
Yeah. Now, there are assumptions also when I talk about the paired samples t-test. First says the dependent variable is continuous and it is measured twice on the same sample of subjects, right? So means we will be having a single variable. That variable will be the dependent variable. That means that variable will be the continuous, or you can say it should be measured on interval or ratio scale. That variable will be the numeric variable, right? As I said, you need to collect data two times for the same variable from the same set of people, right? Second says the differences between the scores of the variable are normally distributed. So here you can see there is a little change in the normality checking of the variable. That means as I am having the marks of the student, 2 marks I will be having. In the first conduct, what he or she has scored, and in the second conduct, what he and she has score, right? So I will take the difference of the scores, and for that difference, I need to check the normality. Third says the differences between the scores of the variable do not present significantly outliers. Means again, whatever the difference I will be having, there should not present any significant outlier in that difference. So if these assumptions are maintained by the data, we can go for performing the paired samples t-test. I think it is simple to understand, right? Shall I go ahead?
Yes, ma'am.
Now talking about the hypothesis formulation in case of paired samples t-test. First one says the mean difference between the variable score is equals to 0 in the total population, right? Simple meaning is that we are taking the two means for the same variable we are collecting the data twice, so we can take the mean of both types of conducts, and we are expecting in the null hypothesis that the difference is 0 in that particular, means mean difference is 0 in that particular score. Alternatively, we can say the mean difference between the variable scores is different from the 0 in the total population, right? So this way we can formulate our null and alternative hypothesis. We can decide upon the significant label. Usually, as I said, in the management field, generally we are taking 5%, but according to your field, you can decide the appropriate level of significance and you can test your hypothesis. Now, what you need to report in the research paper or in your research study. So generally the value of the t you need to report, the degrees of freedom you need to report, the p-value, mean difference, and the confidence interval for the difference you need to report in your research paper. So these are the things which we are reporting when we are performing the paired samples t-test, right? So I think this is clear to everyone, concept of paired samples t-test or dependent samples t-test.
Yeah, ma'am.
Right. So I'm now expecting you to download the sheet I have given in the group named as math data or something, right? So let me check. Yeah, math dash test. I hope you have got it. My file is visible. My file is visible.
Yes, ma'am, your file is visible.
Fine. Why I'm asking again and again, the thing is that probably my system, that is my laptop, is running out of space. So probably I'm unable to cope up with the meeting. So I'm not understanding whether I'm in a meeting or not. So that is why I'm asking again and again. Okay, fine. So shall I go ahead? Do I need to wait?
Yes, ma'am.
Need to wait or may I go ahead?
Ma'am, go ahead.
Fine. So you can see I'm having some multiple columns in the sheet I provided to you. You can go in the variable view. You can check names are grade 1, grade 2, before and after, right? And this all the 4 variables are your scale variable, that is numeric variables, right? Now, as I have given you 4 columns, so you need to only consider the first 2 right now, that is grade 1 and grade 2. Later on, if you wish to practice paired sample status, you can use the second set of columns, which is before and after, right? I'll start with the meaning, or I'll tell you the background of this data. Here you can find I'm having the grade 1 and grade 2. Suppose a test was conducted, right, on a scale of suppose 10, and or maybe the maximum marks were 10, and these were the scores collected from the students. But this test was conducted 2 times, right? So before teaching any particular topic, the test was conducted. So these were the grades or marks. And after that, we are having the again grade or marks when after teaching the concept, again the test was conducted. So these were the scores of that, right? Now we want to see whether the scores are having any significant difference or not, right? So what will be my null hypothesis? Anyone who will try? Yes.
Ma'am, the mean difference of two grades are equal.
Will you please repeat again, ma'am? Mean weights? Monica, ma'am, will you please repeat? I am audible, I hope. I am audible?
Yes, ma'am, you are audible.
Yeah. Monica, ma'am, possible for you to repeat? Okay, fine. So according to me, we can write the hypothesis. If anybody wants to note down, they can note down it. There is no significant difference in the grades before and after teaching. Clear?
Ma'am, can you please repeat again?
Yeah, there is no significant difference
Yes, ma'am.
in the grades
Yes, ma'am.
before teaching and after teaching.
Okay, ma'am.
So shall I go ahead? Note it down, everyone.
Yes, ma'am.
Okay. So now, as we have talked about the assumptions, so we can say here, firstly, the dependent variable is the grade, that is our numeric variable. First assumption we have checked. For the remaining two, that is normality as well as the outliers, you need to firstly calculate the difference of the grades, right? So now, what you need to do, go to the transform and click on compute variable. I hope everyone has identified, located this option. Go to the transform, then select compute variable. Done?
Ji, ma'am.
Done. Now you can firstly in the target variable box, you need to give the name of your variable which you want to compute. So I am writing the name as difference. Up to you, whatever suitable name you are finding, you can write that. I have written difference. Fine.
Yes, ma'am.
Now shift the grade 1 into the numeric expression box using the arrow key. Put minus, then grade 2 and shift it. Done? Fine.
Done, ma'am.
Then click on OK. So you can come to your sheet and can check that one new column added with the name difference. I hope you can see and you are also getting the same. Right. Fine. If it is done, now we need to check the normal distribution of this and also we need to find whether is there any outlier available in the difference or not, right? So go to the analyze now. Then descriptive statistics and explore. Done. Shall I click on explore? Yeah. Then shift the difference into the dependent list box. Click on plots. Select the histogram. Deselect stem in leaf and select normality plots with tests. Done. Shall I go ahead?
Yes, ma'am.
Click on continue. Click on OK to get the output. I hope output is visible. Shall I go ahead?
Yeah, ma'am.
You can see case processing summary table is telling us we are having total 359 scores differences available, no missing values, so total is same. Then descriptive statistics for the difference says the mean difference is minus 1.17. 95% confidence interval for mean says it is the range is minus 1.2 to minus 1.12. Then 5% trimmed mean is minus 1.18. Median is minus 1.19. Likewise, we can read other values. Coming to the skewness and kurtosis, you can see skewness is 0.243, which is nearby 0, but not exactly 0. Kurtosis is also nearby 0, but negative, right? Looking at this, maybe we can say the difference of the score or grades is normally distributed, but still to confirm this, you can come to the test of normality table, and there you can find Shapirovil's test is given along with the significant value, which is 0.108. So I think you can recall, according to the p-value concept, if your p-value or if your significant value is greater than 0.05, we will hold the null hypothesis, right? So in our case, 0.108 is greater than 0.05, yes or no?
Yes, ma'am.
That means we need to hold the null hypothesis, or we will go with the null hypothesis. Anyone who can recall and tell me what was the null hypothesis in case of Shapirovil's test? Anyone?
Ma'am, normally distributed.
Very good. Difference is normally distributed. This was the null hypothesis, and we are accepting this. Getting? So that means normality is passed according to the Shapirovil's test. Coming to the histogram, histogram is also okay kind of, right? Somewhere we can say that normality is obtained or maintained by the difference of the grades. Fine. Done, everyone?
Yes, ma'am.
Fine. Going down, looking at the normal QQ plot, you can see almost most of the points are following exactly the solid line. Some of the points are little deviating from the line, right? Meaning is that there is some deviation. That means this is a problem of little, means your tails will be little far from the x-axis, right? But still, most of the points are following the line. That means we can say that the variable, or that this difference variable, is normally distributed. The trended normal QQ plot, as I told you, we do not need to discuss. We'll come down and looking at the box plot. So looking at the box plot, if you say the box is looking good, but upper whisker, if you will see, beyond this, we are having the 3 outliers, right? And these are the numbers of those students' data. The student coming at number 90, 230, and 264. These 3 students scores or the difference is little going upward side, right? That means this is indicating there are 3 outliers. But if you can recall, status in SPSS, circles are indicating insignificant outliers. That means if they will present, they will not impact that much to your results, right? If these will be coming in the form of asterisk, that means they are impacting your results, right? So that way you can see almost all the assumptions are met by our data. Is it okay? Fine, everyone?
Yes, ma'am.
Now we will go for performing the paired samples t-test, that is dependent samples t-test. So we need to go to the analyze, compare means, and we'll go to the paired samples t-test. So repeating, analyze, compare means, and paired samples t-test. Done? Shall I click?
Yes, ma'am.
Fine. Now, once I have clicked on that, you can see the one dialog box is appearing, right? Here, you can see we are having the variables available in our sheet listed at the left side. So you need to shift grade 1 and grade 2 into the variable 1 and variable 2 box, right? Shifted.
Yes, ma'am.
Clicking on the options, you can see only we are looking at confidence interval percentages, which is 95%. That means level of significance will be 5% there, right? We'll go with the continue, and then we need to click on OK. So in few seconds, in very what I can say milliseconds, we got the output. Shall I go ahead with the interpretation of this?
Yes, ma'am.
Now you can find the first table is the paired samples statistics table. There you can see grade 1 mean is 6.018, grade 2 mean is 7.194. Total means in case of grade 1, we will be having total 359 participants. In grade 2 also, we will be having the same number of participants. The standard deviation in the grade is mentioned in the next column, and standard error of mean is given there in the next column. Going down, looking at the next table, which is the paired samples correlation, right? Which is indicating correlation value is very poor. It is 0.007, almost 0. So usually, it is not acceptable in case of paired sample status. This value should be at least some 0.4, 0.5 something, at least, right? Why so? Because we are using the same person data. So there should be some relationship between them. But this is not coming here, right? Going down, looking at the paired sample status table, you can see the mean of this is coming as minus 1.17. The standard deviation of this is 0.15668. This is the standard error of mean. 95% confidence interval of the difference. And at the last, you can find we are having the t-test value. We are having the degrees of freedom. We are having the significant value. So t value is minus 43.150 for the 358 degrees of freedom, and the level of and the degrees, and the p value is 0.000, which is less than 0.05, right? If my significant value or if my p value is less than 0.05, anyone will tell me what I need to do, whether I need to go with the null hypothesis or not.
Ma'am, it will be rejected.
It will be rejected. Very good. So we will reject the null hypothesis. And if I'm rejecting the null hypothesis, what I'll conclude, I'll say there is a significant difference in the mean grades before teaching and after teaching. Yes or no? Yes.
Yes, ma'am.
Friends, fine. May I continue? It is clear?
Yes, ma'am.
Yes,
Clear.
ma'am.
Fine. Now, if I'm rejecting the null hypothesis and saying there is a significant difference, that means difference is existing. So now there is a meaning of this mean difference, right? Now you can see the mean difference is coming as negative. Meaning is that grade 1 mean is less than grade 2 mean. Yes or no? Only then this will be coming as negative, right? Or you, if you wish, you can see your first table. You can easily see grade 1 mean is less than grade 2 mean. That is why it is coming negative, right? Meaning is that there is an improvement in grades, right? After teaching, mean grades has improved. Yes or no?
Yes, ma'am.
That means if grades have improved, we can say that teaching was effective. Fine, everyone?
Yes, ma'am.
Fine. So this way, friends, we can apply paired sample t-test. If concept is clear, may I go for the one-way ANOVA now?
Yes, ma'am. Clear.
Fine. So give me a second. I need to open my slides. Okay. Visible? Shall I go ahead? Am I in a meeting or not? Hello? Shall I
Ma'am,
go?
your screen is visible, ma'am.
Yeah, actually, I'm repeating why I'm asking again and again. It is because of my system is out of space now. So I'm not able to understand whether I'm in a meeting or not. The Google meeting is not loading in my system right now. So that is why I need to ask again and again. Okay, fine. So I'll go ahead and talk about the new concept for the day, which is the one-way ANOVA, right? So ANOVA is the extension of t-test, right? So firstly, we will understand what is this, and then I'll talk about it. So when I talk about one-way ANOVA, that is one-way analysis of variance. It says, or it is given by Sir Ronald Fisher. He was the British statistician. So after his name, as his surname is Fisher, right? So after his last name, we also know this thing. If people have applied ANOVA, that the ANOVA is represented by F statistic, right? So it is coming from his last name. So we can say this particular ANOVA is also helping us to find the significant mean difference. So as I said, it is the extension of the t-test. So t-test is doing what for us? It is also finding the significant mean difference for us, right? ANOVA is also doing the same task, right? So the difference comes in the independent samples t-test and in the one-way ANOVA. That means independent samples t-test can compare only two groups, whereas one-way ANOVA can compare difference in the mean in more than two groups. So when you are having more than two groups, you need to go for one-way ANOVA. Purpose is same of independent sample t-test and one-way ANOVA. Both are doing the same thing, finding the significant mean difference. But if I'm having more than two groups available, in that case, T cannot do that thing. That T cannot compare all the groups mean together, but ANOVA can do for this. Is it clear?
Yes, ma'am. Clear.
ma'am.
Yeah. So that means I can say, as I will be having also the independent variable in case of one-way ANOVA. So in one-way ANOVA, there should be at least three groups available, right? Right. One more thing this slide is telling you, that is ANOVA is a precursor to general linear modeling. So on Monday, when I talk about the regression concept, in that case, you will see ANOVA is also coming as one of the output, right? So ANOVA will help you there to ascertain whether the linear model can be developed there or not, right? Now coming to when you can use one-way ANOVA. So as I said, when you want to find statistical or maybe significant differences among the means of two or more groups in that case, or maybe between or among the means of two or more interventions, or maybe among the means of two or more change scores. In all these cases, one-way ANOVA can be applied, right? Now, coming to the variable requirement in case of one-way
Yes,
ANOVA.
ma'am.
Yeah. So in case of variables requirement, in case of one-way ANOVA is similar as the independent sample t-test. So I think you can recall yesterday when I was talking about independent sample t-test, I have clearly told you we are requiring two variables. One is dependent, one is independent. Dependent variable is continuous, that is numeric. Independent variable will be categorical. So the same variable requirement will be there also in case of one-way ANOVA. We are requiring one dependent variable and one independent variable. That independent variable is also known as grouping variable or factor variable, right? So This variable divides the cases into two or more mutually exclusive labels or groups. Meaning is very simple. That means you need to have a categorical variable and there should be at least 3 groups present if you want to perform one-way ANUVA, right? So dependent variable measurement, I already told you, it should be numeric variable that is continuous or interval or ratio scale variable. Independent variable should be the categorical with at least 3 labels, that is 3 groups or 3 categories. So one example, suppose here you can see marks and there are 3 teaching methods, right? So you can see marks is your numeric variable, that is your ratios, that is your interval scale variable, and the discussion, audio and video, these are the teaching methods which can be the categorical, right? So teaching method is the categorical variable with the 3 different groups. So if you wish to compare the marks, students who are studying from discussion method, audio method and video method, whether there is a significant difference existing in their marks or not, you will go for the one-way ANUVA. Is it clear?
Yes, ma'am, clear.
Now
Yes.
talking about, yeah, thank you everyone. Now talking about the assumptions. First assumption says it is related to the assumption of independence. That means whatever the 2 or more groups you will be having, they should be independent of each other. So if you can recall, I told you how to maintain the independency in the data. If you are very much sure, or if you are making sure this thing that a one person will be part of one group only, he or she will not give you responses more than 1 times, you can maintain this assumption, right? Second says assumption of normality. So always normality is we are applying on the numeric variable, and in case of one-way ANUVA, numeric variable will be the dependent variable, right? So you need to check whether your dependent variable is approximately normally distributed or not, right? Next says assumption of homogeneity of variances. So assumption of homogeneity of variances meaning is equal variances or equality of variances, right? So that means your numeric variable should have same variance in all your groups, right? So that you can check using the relevance test, right? Last one says there should be no significant outliers. So in your data, significant outlier should not present, right? This is in case of the dependent variable. In dependent variable, there should be no significant outlier present, right? So this way, these are the assumptions of one-way ANUVA. If suppose your data is violating the assumptions of ANUVA, generally, as I said, we are having one substitute available in the non-parametric test category. And for one-way ANUVA, it is Kruskal-Wallis test, right? Till here, I am clear.
Yes, ma'am.
Fine. Now, this is the same repetition of the graph I have shown you yesterday in context to the normality checking using the histogram. Then Levens test also I discussed yesterday. So I'm just recalling this thing for you people. If you are not remembering this, I told you Levens test is used to check the whether the variable is having same variance or not, right? So you can say it is for the equality of variances or homogeneity of variances. So the null hypothesis will be variance is equal, or the variance of dependent variable is equal in all the groups. This is the meaning, or this is the null hypothesis. Alternatively, you can say variance is not equal of the dependent variable in all the groups, right? So this way, this is the Levens test. Now, hypothesis, if I'll come to, you can see symbolically, I have written here the hypothesis as X naught says whatever number of groups I am having. Suppose I am having the K number of groups. So my null hypothesis says mu1 is equals to mu2 equals to mu3 up to equals to mu k. Means whatever the number of groups I am having, I am assuming their population mean are equal, right? Alternatively, I can say at least one mu is different, right? Maybe the second group mean is not matching with the other groups, or maybe the fourth group mean is not matching with the other group, or maybe anything, right? But at least one mean is different. This is the meaning of the alternative hypothesis. Now, talking about if you have anytime if you people have performed the one-way ANUVA, using the or by doing the manual calculations. So we know this thing. We need to do so many calculations, right? And then we need to prepare a ANOVA table. So in the output of SPSS also we will get the similar kind of table, right? But remaining calculations it is not showing. I think it is not needed because it is a software. But final table will be presented like this only. So there you can find we will be having a treatment, we will be having the error value, we will be having the total, and column will be sum of squares, degrees of freedom, mean sum of square, and the F best. As we are performing using the software, we will also be having the significant values, right? Now, how to perform one-way ANOVA? I think this is the slide for that. I think this is about the conceptual understanding about the one-way ANOVA. Shall I go ahead now how to perform one-way ANOVA using SPSS?
Yes, ma'am.
Fine, thank you, ma'am. So expecting you to open the sheet I provided you yesterday, named as employee data. So if you people are ready, please tell me. We will proceed to perform one-way ANOVA on this data. Shall I go ahead? Do I need to wait?
Ma'am, start please.
Yeah, thank you, ma'am. So you can see, I think you people are acquainted with this particular data. I already shown you the data, and we are knowing what type of variables available here. You need to only pick the two variables on which you want to perform the one-way ANOVA, right? So you can see in the variable view, I am having few of the what I can say, the categorical variables, right? That is nominal or ordinal scale variable. Out of which you can find I am having the gender, which we have already seen yesterday. There are two groups only. But for one-way ANOVA, we need to have three, right? So maybe I'm picking the job category, which is containing the three groups: clerical, custodial, and manager. So this will be my one categorical variable, and the numeric variable I'm taking as a salary. So I can say I want to compare the salary on the basis of job category. This is the purpose, right? Now anyone who can try to or can attempt to make a null hypothesis for these two variables, that is job category and the salary. Anyone? Hypothesis will be very similar like the independent sample status, as we have already talked. It is the extension of the independent sample status. So anyone who can try to formulate the null hypothesis using the variables salary and job category.
Ma'am,
Anyone?
salary in all job categories are equal.
Very good. It's Monica, ma'am.
Ma'am.
Very good. Thank you so much, ma'am. Ma'am has said very correctly, right? Ma'am said fine. Ma'am said that the salary in all the three groups is equal, right? Usually, you can also write it like this. There is no significant difference in the mean salary or mean salaries of the employees on the basis of their job category, right? One and the same thing. Whatever way you are liking, you can write your hypothesis in that manner, in that fashion, right? Now, if a hypothesis is clear, we will go now firstly for checking of the assumptions. So I think assumption is variable should be numeric, that is dependent variable, which is, you can see we are having a numeric variable. Category or categorical variable is the job category, and in which we are having the three groups, right? Now further, we need to check the normality, outliers, and the variances. For that, we will go to the analyze, and then descriptive statistics, and then explore. I think now you people will be acquainted and you people have easily located this. May I click on explore now? Am I in a meeting? I think yes. Hello?
Ma'am, we can hear you and see the.
Yeah, fine. Thank you. Go to the Analyze Descriptive Statistics and click on Explore. After doing this, I am resetting this, right? And then I'll shift the current salary into the dependent list box and the job category into the factor list box. Done?
Yes, ma'am.
Now click on the plots and same histogram and normality plots with tests. These two check boxes you need to select. Stem and leaf you need to deselect. Done?
Done, ma'am.
Click on continue and then OK. So shall I go for OK?
Sir.
Yes. May I click on OK?
Please
Yeah.
proceed.
So you can see we are getting the output in the output where I think it is not generated. Yes, generated. Now you can see case processing summary. We are having the three categories in the employment category, which is clerical, custodial, and manager. 363 are the clerical staff, 27 are custodial, 84 are managers, right? There is no missing value in the data. So valid and total is similar. Descriptive statistics you can find here for the current salary. According to the three categories, we are getting the three sections of this table. First one is the clerical. So the mean clerical, that means the mean salary for the clerical staff is 27,838. The median of the same is 26,550. Skewness is 1.905. Kurtosis is 7.977. So both these figures are very, very large. That means these are violating the normality parameters or normality assumption, right? That means we can say that the salary of the clerical staff is not normally distributed. Coming to the custodial section, mean salary for the custodial staff is 30,938. Their median salaries are 30,750. Skewness is minus 0.368. Kurtosis is 3.65. Looking at the skewness and kurtosis figure, skewness is not exactly 0 and kurtosis is beyond 3, right? So that means it is again giving us a clue that the salary for the custodial staff is also not normally distributed. Going to the last section of the table, which is for the managers, that you can see the manager's mean salary is 63,977. Median for the same is 60,500. Skewness is 1.181. Kurtosis is 2.107. Again, looking at these two last figures, we can see that the normality assumption is not maintained by the salary of the managers. Is it clear? That means somewhere it's looking at this skewness and kurtosis, we are able to comment this, that the salary is not normally distributed for all the three staff of all the three category employees. Is it clear?
Yes, ma'am, clear.
Okay, coming down to the test of normality table, looking at the Shapirovil's test, if you will look at this directly the significant value, that is the p-value, you can find all the p-values are less than 0.05. Meaning is very simple. It is indicating that the salary variable is not normally distributed either for clerical staff or for custodial or for manager. For neither of the categories, the salary is normally distributed. Is it clear?
Yes, ma'am, clear.
Then, coming to the histogram, you can find histogram is clearly indicating this is for the clerical staff, which is indicating it is right skewed, positively skewed. And if you will see the bars, when the salary, x-axis salary, because salary is coming on x-axis, when it is increasing, That means there are less number of people who are drawing these big figures in the clerical category. Similarly, in coming to the custodial, although the graph is not that much good because the sample size is very small here, which is 27 only, right? So it is again not giving you better picture of the normality when you will look at the histogram of the custodial category. Talking about the manager category, here you can see the histogram, which is again depicting us that salary at the higher side. There are very less number of people who are drawing the higher salary, right? So that way we can say for the manager staff also, the salary is not normally distributed. It is right skewed or positively skewed. Looking at the QQ plots for clerical staff, positively skewed. For custodial, positively not. It is not giving us the clear picture. For the manager, again, it is positively skewed. It trended, you can skip. Coming to the box plot, which is helping you to understand the outliers in the data or not, whether the outliers are present or not. So once you will look at all the three category box plot, you can find in the clerical, if you will see, there are 2 asterisks. These are the significant outliers. Here also there are 2-3 asterisks in the custodial staff also. That is the significant outliers. In the manager, you can find only a single star available. That means there is one significant outlier, right? So that means that way, if you will comment on normality, so possibly you can say this thing, normality is not maintained by the salary variable for all the 3 categories. But if you will discard or remove these outliers, so maybe somewhere it can help you to improve the normality of the data. So this way, 2 assumptions, that is normality as well as outliers we have checked. But for understanding the Levens test output, you need to go to the ANOVA. Is it clear?
Yes, ma'am, clear.
Now we'll go to the analyze. We'll go to the compare means, and then we'll select the last option, which is one-way ANOVA. So repeating, analyze, compare means, and one-way ANOVA. So you can click on this. So the dialog box will appear like this. I hope it is okay. Shall I go ahead? Yeah.
Please go ahead.
Fine. Click on the current salary, shift it into the dependent list box. Then employment category, that is job cat, into the factor list box. Then done. Shall I go ahead?
Done, ma'am.
Contrast, yeah, thank you, ma'am. Contrast, we will explore later on. Post hoc, meaning I'll explain you again afterwards. We'll go directly to the options. Click on the options. Here, descriptive and homogeneity of variance test. These 2 check boxes you need to select. First and third checkbox. Then, if done, click on continue and then OK. So I think I am clicking on OK. I have generated the output now. Shall I go ahead with the interpretation now?
Yes, ma'am, output is generated.
Done. Thank you, ma'am. You can see, first one is the descriptive statistics table, which is indicating us the number of respondents or number of employees in each category, first column. Next column is indicating you the mean salary of these 3 categories. Then standard deviation in the mean salary, standard error of mean for all the 3 categories, 95% confidence interval for mean at minimum salary and maximum salary in all the 3 categories is mentioned in the first table. Coming to the Levens test. Test of homogeneity of variances, if you will see here, you can find current salary. As I told you, for understanding the third assumption, which is related to the homogeneity of variances or equality of variances, you need to take the help of Levens test, right? So you can see Levens test statistics is mentioned. We will go with the based on mean, as it is related to the numeric variable, we'll go with the mean and we'll find the significant value is coming as 0.000, which is less than 0.05. So if it is less than 0.05, that means we will not hold the null hypothesis of Leven's test. And if you can recall, the hypothesis of the Leven's test was there is equal variance, right? Right? Variance is equal was the hypothesis. I hope you people are listening to me. Shall I go ahead?
Yes, ma'am.
Fine. So after understanding that homogeneity of variances is not maintained by the data, if suppose I'll go to the ANOVA table, there you can find, as it is coming same format which I have shown you, sum of squares, degrees of freedom, mean sum of squares, F value and the significant value. There you can see the F value is 434.484 and the significant value is 0.000, which is less than 0.05. So in case of ANOVA, we will not hold the null hypothesis. And what we will conclude? We will conclude there is a significant difference in the mean salaries of employees on the basis of their job categories. Is it clear? Any doubt? Shall I go ahead?
Yes, ma'am, you can.
Okay, fine. So we can say this thing. ANOVA output is saying there is a significant difference, right? Now comes to the drawback, or maybe we can say the limitation of the ANOVA. Not the drawback, it is a limitation of the ANOVA. We can say this thing. ANOVA, if you can recall, I told you ANOVA null hypothesis says what? It says alternative hypothesis says what? At least one mean is different. Meaning is that if any of the mean, means for any category, if the mean is not equal to the remaining category, ANOVA will declare this thing that there is no significant difference. Is it clear? So that is a limitation of the ANOVA. Is it clear? What I said is clear to everyone? Yes or no? I haven't heard.
Yes, ma'am. Yes, ma'am.
Fine. Thank you. So this is the problem or limitation with the ANOVA, right? So that means it is not telling you the pairwise comparisons. Pairwise comparison meaning is what? Clerical and custodial staff salary significantly different or not? It is not. You can get with the ANOVA output. Custodial and managerial staff salary significantly different or not? You cannot comment using the ANOVA output. Similarly, clerical and managerial staff salary significantly different or not, that you cannot comment using the ANOVA output. So for that, you need to go for the multiple comparisons or post hoc test, right? So now again, I'll go to the analyze and we'll see how to perform post hoc test. So click on the analyze, compare means, and then one-way ANOVA. This time, you need to click on the second button, which is the post hoc test. Done, everyone? Shall I go ahead?
Yes, ma'am. Ma'am, 1 minute.
Fine.
Ma'am, go ahead.
Fine. Thank you. You can see, ma'am, here we are having the two sections of this particular box. One is saying equal variance is assumed. Second says equal variance is not assumed. So if you can recall that Leven's test results, Leven's test said equal variance cannot be assumed by us, right? We have rejected the null hypothesis of the Leven's test. That means in case of post hoc test, we need to go in this section, which is labeled as equal variance is not assumed, right? Fine.
Yes, ma'am.
Here you need to go to the Dunnett T3. This is the mostly used test in case of equal variances not assumed. Now, if suppose variance is equal in your data case, you should go for the second column, second option, that is CUK by 2K. Getting my point? In case of equal variances, this is the
Yes,
most
ma'am.
widely used test, that is 2K. And in case of not equal variances, this is the mostly used test. You can click on continue and click on OK. So the same output you are getting along with one extra table, which is the post-hoc test table or multiple comparisons table. So I think I can explain you the meaning of this now. Now you can see here there are three sections: clerical categories compared with the remaining two, custodial is compared with the remaining two, managerial is compared with the remaining two. So that means there are multiple repetition is there in the table as it is possible. And when I'm having the three three categories, so only three comparisons are possible. One with two, two with three, and one with three, right? So that means we will compare the clerical and custodial. So you can see significant value is 0.000, which is less than 0.05. That means we will not accept the null hypothesis, or we will reject the null hypothesis. That means we can say this thing, that there is a significant difference in the mean salaries of clerical and custodial staff. Similarly, for the clerical and manager, if you will see, the significant value is 0.000, which is less than 0.05. That means again we will say there is a significant difference in the mean salaries of clerical and managerial staff. Then last combination is left with this, which is custodial and manager. As clerical and custodial is already compared, so I am custodial and clerical, I am not comparing here. I'll directly go to the custodial and manager. So you can see significant value is 0.000, which is again less than 0.05. We can say there is a significant difference in the mean salaries of clerical and the custodial, custodial and the managerial staff. Right? It is clear?
Yes, ma'am.
Fine. So that way you have seen what is ANOVA, what is its limitation, and when we need to go for the post-hoc test. Now the last thing I'll explain you, if you can recall, I told you I have not touched this contrast button. So shall I go now for contrast button?
Yes, ma'am.
Click on the contrast button here and then come to the coefficients. Here, this particular option is providing you an opportunity to perform t-test here in case of ANOVA. In case of ANOVA, we can go for getting the output of t-test also using this particular contrast button, right? So as we know this thing, in case of t-test, we can compare only the two categories or two groups. So that means I need to firstly decide here, as I am having total 3 groups available, in which two groups I want to compare the mean. So which two groups I should compare? Clerical, custodial, and manager. These are the 3 groups. Which two groups I should compare?
Ma'am, I think first two.
Clerical and custodial?
Yes,
Fine.
ma'am.
Okay, thank you so much, ma'am. So if we are comparing the first two groups, so meaning is that I need to allocate some coefficient to these two categories which I want to compare. So any number you can think or you can supply here. Suppose I'm using a very small number, that is 1, right? I'm adding it. That means for clerical I have given 1. Now for the second category I need to use the same number with the minus sign, that is -1. And as I do not want to include the third category, I will give it to 0. Meaning is that this coefficient total should always come as 0 if I want to perform the t-test. That it is clear. Suppose I am giving 5 to the first category. So for the second category I need to give -5. Is it clear?
Yes, ma'am.
Then click on continue. And then if you wish, or if you do not need to see all these things, you can deselect this so that you will get a very small number of output or tables in the output. So now you can see. You are getting here the contrast test table. Remaining columns are okay. We will not discuss that because these are similar. You can see here the contrast table is containing the t-test value, right? Its degrees of freedom and the significant value. So as we have already checked, variance was not equal. That means we'll go to the next second row. Does not assume equal variances. This row we will opt for. T will be reported as -5.452. the degrees of freedom will be 93.072, and the p-value is 0.000, which is less than 0.05. That means what I'll comment there is a significant difference in the salaries of clerical and custodial staff. Is it clear
Yes, ma'am.
to everyone? Okay. So I think now I'll go to the summarization of the session, and then I'll take your queries if you are having any. Till here, no doubt, till whatever thing I discussed right now. Can I go ahead for the conclusion of the session?
Yes, ma'am.
Fine. Thank you so much, Anchal ma'am, for actively participating and interacting with me. Thank you. Okay, so I can say we have started today with the dependent samples t-test, right? That is the two samples t-test category test, where we have understood the concept that when you want to compare two dependent samples, you will go for the dependent samples t-test. Dependency meaning is here what? That means you need to keep collect the data from the same group of people twice. There will be some time gap in that those conducts, in those data collection processes, and that way you can say you are able to maintain a dependency of pair-wise comparison, or pairing you are able to maintain. In that case, you will go for the paired samples or dependent samples t-test. Then we have talked about its assumptions. So assumption which were important in case of paired sample t-test were, you need to see this thing that the difference of the scores, the difference of the scores should be normally distributed, and there should be no outlier in that, right? So that is the important thing. So that means whatever the two conduct you are doing for your variable, you will take the data of that, and you will get the difference. In that difference, you need to check there should be no outlier, and it should follow the normality, right? And if it is okay, you will go for performing the paired samples t-test. You will interpret their results and can conclude your results. Then talking about the next concept which we have discussed was the ANOVA, that is analysis of variances, and we have seen the one-way ANOVA. In that, we have understood this thing that one-way ANOVA is the extension of the independent samples t-test, because purpose is same. We want to compare the means, right? So when you want to compare the means, both the tests are applicable. But if you are having more than two groups, means if you want to compare more than two groups simultaneously for the mean, you will go for the one-way ANOVA, as t-test cannot compare more than two groups together, right? T-test can compare only the two groups together. So this was the understanding of the one-way ANOVA. We have understood its assumptions, which were very similar to the independent samples t-test. We have seen how to check these assumptions, and then we have seen how to perform ANOVA. I also told you if ANOVA output says that you are rejecting the null hypothesis, in that case only you should go for the post hoc test, that is the multiple comparison test. And using the multiple comparison test, you can compare all the possible pairs, and on the basis of significant value, you can comment whether the significant difference is existing in those pairs or not. Apart from that, I also told you what is the use of the contrast button. It is helping for you to understand or to get the results or output of the t-test in the one-way ANOVA setup, right? So friends, this was about the crux of the session for the day. Now I'm opening to take your questions if you are having any questions, any queries. So shall I go ahead? Friends, am I audible?
Yes, ma'am.
Yeah. Any queries?
No, ma'am.
Okay. Fine. So, what about the remaining persons? No queries? Yeah. Shall we wind up the session for the day?
Yes, ma'am.
Yeah. Thank you so much, Anchal ma'am. Fine. So friends, if there are no queries, we are ending up the session. By tomorrow, probably I'll give you one link through which I am expecting you to fill your responses that we can discuss on the session on the day 7, that is on Tuesday. Right? Fine.
Yes, ma'am.
Thank you so much.
Yes, ma'am.
Thank you, everyone. So we are done for the day. Thank you for your questions, listening to me. We are meeting now on Monday. I think Sunday there will be no session. Yogesh sir? Sir, are you there? Yogesh sir, are you there? Okay, I think sir is maybe busy in some task. Okay, friends, I think we can leave. We are meeting on.
Yeah, ma'am.
Yeah. Okay.
Thank you so much, ma'am.
Thank you,
so
Anchal
much.
ma'am. No problem, Brahma ma'am. It's okay. I can understand. Fine, no issues. So we are meeting now on Monday for the second last session where I'll talk about the correlation and regression using SPSS. Thank you so much, everyone. Good night. Take care.
Okay, ma'am. Thank you. Good night.
Good night.